In this video, we're going to do some practice problems relating to the theorems about definite integrals found in the last video. So let's start with this example. Given that the integral from 0 to 1 of x e to the negative x squared is 0.316, and the integral from 0 to 1/2 is going to be 0.110, find the following integrals. So note that we have this complicated function, x e to the negative x squared, but we're not really going to deal with this function in any capacity in this problem. We're just going to be dealing with the bounds and kind of moving around the integral. We'll see how we're going to do that. So before we even jump into what we have, or what we're looking for, let's see what we have. We start with the fact that the integral from 0 to 1 of x e to the negative x squared is 0.316. So in the picture, this is going to be the area under the curve from 0 to 1. This area is equal to 0.316. We are also given that the area from 0 to 1/2 is 0.110. And we're going to use that information to find the total or the following areas. Let's start with the area -1 to 1. And notice that x e to the negative x squared is an odd function. The reason it's odd is because f of negative x is equal to negative f of x. It's symmetric about the origin, but that means that this integral, -1 to 1, is going to be equal to 0. There's going to be a positive part and a negative part, and they're going to counterbalance each other. So we start with this fact that this is equal to 0. Now let's move on to the other ones. And I think it's actually better to start with this third one here, integral from 0.5 to 1. That is this chunk. And note that we can use the values that we have to build this 0.5 to 1 chunk. We can write this as the integral from 0 to 1 of x e to the negative x squared dx minus the integral from 0 to 0.5 x e to the negative x squared dx. We're taking the big chunk in blue, subtracting off that piece in red, and we're left with the piece in yellow. So we know what these values are. This is going to be 0.316, and we're going to subtract off 0.110, and that's going to give us a total of 0.206. So that's our second answer to part C. And finally, we can now deal with the integral from -0.5 to 1. In the picture, we are dealing with -0.5 to 1. The area in blue, that 0 to 1, plus this little bit from -0.5 to 0. There are a lot of different ways we could go about finding this value, but I'm going to use the fact that this is equal to -0.5 to 0.5 x e to the negative x squared dx plus the integral from 0.5 to 1 x e to the negative x squared dx. And those are two values that we know. This first one, because the function is odd and we are going about the origin there, -0.5 to 0.5, that's just going to be equal to 0. And then the yellow part we found in part C, that's going to be 0.206. This is also going to be equal to 0.206, just like the last one. So there's lots of different ways you could go about finding those values. This is just one such way of doing it. Next problem, evaluate the integral from 0 to 3, 2 plus 4x by breaking up the integral into manageable pieces. Then we're going to do the problem again by finding an antiderivative and using the fundamental theorem of calculus. So the idea is that 2 plus 4x, even though it's not that complicated of a problem or complicated of a function, we can break it up into even simpler functions. And we can do that by writing this as the integral from 0 to 3 of 2 plus the integral from 0 to 3 of 4x. And we'll go even one step further, and we'll write this as the integral from 0 to 3 of 2 dx plus 4 times the integral from 0 to 3 of x dx. And there's two different areas that we have to find here. First one, we have from 0 to 3, the constant function 2, and we're trying to find the area under the curve from 0 to 3. And that area is just a rectangle, and it's going to be the base 3 times the height 2. That's going to be a 6. This whole thing is going to be equal to 6 plus 4 times whatever we get for our next one as well. So the next one is the integral from 0 to 3 of x dx, and x is a function, a line, going through the origin with a slope of 1. And it's somewhat nice to deal with because we think about 0 to 3, we know the y value associated with that because it's just going to be the x value. That point of the function is 3, 3. And when we're looking for the area under the curve, we're finding the area of this triangle. The area of a triangle is 1/2 base times height. That's going to be 1/2 3 times 3, or 9/2. So total, we have 6 plus 4 times 9/2. That's going to be 6 plus 18, or 24. And again, it's kind of breaking these functions up into their bare bones by using some of the results that we found in this section. Now we're going to do this problem again, and this is probably how we're going to do this problem usually, by finding an antiderivative. The reason we're not really doing this all the time yet is because that's a chapter 6 material, but it's good to get some practice with it early on. So we need to find an antiderivative. That is, we have to find a function whose derivative is 2 plus 4x. So we're going to do it piece by piece. So first of all, let's think about a function whose derivative is 2. And I think you should pause the video at this point and think about a function whose derivative is 2, and then also a function whose derivative is 4x, and try to see if you can build those functions. So if you've done that, now you know that a function whose derivative is 2 has to look something like 2x. It's going to be the slope of a line, and the line has to be 2x. The derivative of 2x is 2, so that's what we're trying to find. A function whose derivative is 2 plus 4x, so we're doing one piece at a time. For 4x, we have to think about the derivative of something with x squared. The derivative of x squared is 2x. And if I want to get a 4x, I just need to multiply everything by 2. Here we have the derivative of 2x squared is 4x. So our function that we're looking for, whose derivative is that, is 2x plus 2x squared. And now I'm going to use the fundamental theorem of calculus. The integral from 0 to 3 of 2 plus 4x dx is equal to an antiderivative, 2x plus 2x squared, evaluated from 0 to 3. I'm going to plug in the top bound, 2 times 3 minus 2 times 3 squared in parentheses, and then subtract off, plugging in the bottom bound. And we get a 6, it should be a plus, sorry, 6 plus 18 minus 0, and that's all equal to 24, which is what we should get because we're doing the exact same problem as we did before. So note that as we go further in this course, that's how we're going to do these problems usually, but since we haven't really introduced antiderivatives fully, we can still think about it as area of nice functions and use these properties that we have. So the next example deals with a function being odd. It's going to be somewhat reminiscent of the first problem we did in this video. We have that a function is odd and the integral from -2 to 3 is 30. We want to find the integral from 2 to 3 of the function. So let's think about a little number line here. We have -2 and 3, and we know that the integral from -2 to 3 of the function is 30, and we want to find the integral from 2 to 3 only. So we need to break this up into a manageable piece, and since the function is odd, the best way to do this integral from -2 to 3, is to write it as the chunk from -2 to 2, which is really nice for odd functions, plus the chunk from 2 to 3. And why it's nice for odd functions is because that's going to be just a 0. And we're given that the entire thing is 30, and we're looking for this integral, which means that we've set up an equation, and it's very easy to solve is because the 0 is there, and we have that this integral is also equal to 30. And that's very similar to something we did in that first example with a little bit of a different context. Now let's look at an even function. So here f is even. We have the integral from -2 to 2 of f of x minus 3 dx equals 8. And we're looking for the integral of 0 to 2 of f of x. And note that we're only looking for f of x, not f of x minus 3. So first of all, we should probably deal with getting rid of that 3 in there. And we can do that by breaking this up into two different integrals. The integral from -2 to 2 of f of x dx minus the integral from -2 to 2 of 3 dx. And the nice thing about this integral is we can think about it as the area under a constant function from -2 to 2. And that's going to be a base of 4, a height of 3. That's going to be 12 units. So this is going to be equal to 12. We know this whole thing is equal to 8 from before. So now we have this little equation. The integral from -2 to 2 of f of x dx minus 12 is equal to 8. So the integral from -2 to 2 of f of x dx is equal to 20. Now that's not what we're really looking for. We're looking for the integral from 0 to 2 of f of x dx, from 0 to 2, not -2 to 2. But using the fact that f is even, we know that this is going to be equal to 2 times the integral from 0 to 2 of f of x dx. And if that's equal to 20, then we know that what we're looking for is equal to 10 by dividing by 2. So it's using these little facts about even and odd functions and then being able to break the function up to get our result. Lastly, we have a problem dealing with the average value of a function. So we're given two integrals, one that deals with 3x squared, one that deals with 2x on the interval from 1 to 3. And we want to find the average value of f of x equals x squared minus x over that interval. So let's remember that average value of f of x over the interval 1 to 3 is going to be 1 over b minus a, 1 over 3 minus 1, times the integral from 1 to 3 of the function x squared minus x dx. So that's going to be equal to 1/2 times the integral from 1 to 3 of x squared minus the integral from 1 to 3 of x dx. And these are the two things that I'm going to need to find in this problem. So to find the x squared one, I'm going to use this first fact that the integral of 3x squared is equal to 26, and I'm going to work around that. I'm going to write this as 3 times the integral from 1 to 3 of x squared dx equals 26. And I can write this then as the integral from 1 to 3 of x squared dx is equal to 26 thirds. And I can plug that in here, 26 thirds. Now we're going to multiply everything by 1/2. And now I need to find the integral of x. And I'll do that down here. We know that 2 times the integral from 1 to 3 of x is going to be equal to 8, bringing that 2 out in front, just as we brought the 3 out in front before. And then this gives us that the integral from 1 to 3 of x dx is going to be equal to 8 divided by 2, or 4. So now we have our answer. We just need to simplify it. This is going to be 1/2, 26 thirds minus 4. We can write this as 26 thirds minus 12 thirds. 1/2 times 14 thirds, 14/6 is the average value of the function x squared minus x over that interval.